So this video is about problem 5.2 from chapter 5. It's about a guy parasailing behind a boat. Now, in parasailing, you are dragged behind a boat and you're wearing a parachute. So the parachute's attached to your back, and the force of drag lifts you up, and so you're flying along after the boat. So the boat's driving, and then you are attached to a rope. I think it's usually attached to your harness, and then you have a parachute on, okay? And the parachute keeps you up in the air, and it's usually at a higher angle so that it can keep you above the water, okay? So, in the sport of parasailing, a person is attached to a rope being pulled by a boat while hanging from a parachute-like sail. A rider is towed at a constant speed by a rope that is an angle of 15 degrees from the horizontal. Okay? The tension in the rope is 2,300 newtons, and the force of the sail on the rider is 30 degrees from the horizontal. All right, so let's read the problem carefully and then we will solve it. Okay. In the sport of parasailing, a person is attached to a rope being pulled by a boat while hanging from a parachute-like sail. A rider is towed at a constant speed by a rope that is an angle of 15 degrees from the horizontal. The tension in the rope is 2,100 newtons. The force of the sail on the rider is 30 degrees from the horizontal. And what is the weight of the rider? All right, so let's draw a picture, and we will draw all of the different things that are going on inside of this problem. Okay, so I'm going to stop sharing the problem now, and we're going to draw a picture. So first of all, hey, let's start by drawing the boat, and we're going to get all the angles and everything in here. Okay, so here's my boat, and it is in the water. It's going pretty fast. Okay, and it says that the rope is 15 degrees above the horizontals. Okay, so here's about 15 degrees. So it is 15 degrees right there. So that we'll call this angle phi. Okay, and over here I'm going to write phi equals 15 degrees. Okay, and then here we have the guy on that is attached to us. We'll draw him like that. Okay, he looks like a caterpillar, something. Okay, and there's a tension in the rope here, T, and it tells us that the tension is 2,100 newtons. Okay, this is just what's in the problem. Then it says that there's a sail attached to this guy, and it's at a 30-degree angle. Okay, so it's at a different angle here. Okay, so here's his thing, and this is going to be, we'll draw this, we'll draw this as angle theta here. Okay, and we'll say that angle theta equals, that is 30 degrees. Okay, and so his sail, his big parachute is over here like this. Okay, so here's his sail. All right, so this is everything that's going on in the problem. Okay, this is what the problem gives us. And so there's going to be, so let's identify all of the forces acting on this guy. Okay, so we're going to have tension going down this way. Okay, that's one force. Okay, so this is the tension in the rope that's attached to the boat. Then we're going to have the force of the sail going up this way. So I'm going to draw it kind of like this one. Okay, so this is F of S of my sail here. Okay, we don't know what that one is. Didn't tell us. That's one. And then So are these the only forces acting on it? The answer is no. We forgot an important one, which is going to be m times g, his weight. Okay, which is what we are after. Okay, so we want to know what his weight is, and the weight is acting down that way. Okay, so those are all the forces that are acting on him. Okay, so we have his weight, we have the tension, and we have the force of the sail. Okay, so those are all the forces. Now, what we need to do, so first we identified the forces. Okay, that's step one to solve this problem. Identify all forces. Okay, step two. Okay, we're going to find the x and y components. Find x and y components. Right? Now we need to break it down and say, okay, what's acting on him in the x direction and what's acting on him in the y direction. All right. Well, in the y, let's start with the y direction. Okay. This sail is keeping him up in the air, right? We've got the force of his weight pulling him down, and the sail is pulling him up. Okay, so we're going to say this is f of sy. And we're going to make a triangle here, right? That is the side of our triangle here, right? Or at least this is a force that's acting on him. Okay, so we'll call this f of sy. That's the y component of the sail force here. Okay, now we've got his weight going downwards, but there's also this cable, right? The cable is also pulling him down, so we've got a component of that too. So we'll call this the y component of tension. So this will be ty. Okay, so we've got just in the y direction, we've got his weight, we've got a component of the tension here. Okay, um, and we've got the force of the sail that pulls him up. Okay. Now, in the x direction, right? Let's talk about all of the components of these forces in the x direction. Okay. So the force pulling him forward is from the cable. Right. And so we'll call that the tension, force of tension, the x component of the force of tension. Here's our force of tension. Okay. And you'll notice that these are, just components of our vector tension here. Okay, this is just the x and y component of the tension. Okay, well, the only force pulling him back is from the sail. Okay, so now over here, we're just going to draw the x component of the force of the sail. Okay, so we'll call this f of s of x. Okay, so we've identified our x forces and we've identified our y forces. Okay, so we find x and y components of the force. Now, another important thing is the problem tells us that it's traveling at a constant speed. Okay, a rider is towed at a constant speed. Okay, so step 3, set x and y components. Well, how can we say this? Set the x and y components in net force equations. All right, now if you watched my last video, okay, we talked about how if something is moving at a constant velocity, okay, that means that the forces are balanced. Okay, so that for maybe this is part of step 3. Recognize forces are balanced. What does that mean? Well, forces left equal forces right. Okay, so forces left equal forces right, and forces up equal forces down. Right? I'm trying to be really methodical because there's a lot of stuff going on in this problem. And so we're just trying to keep track here of all this stuff. All right. So forces left equal forces right. And that is so important. Okay. Is recognizing that you have that the forces are balanced. Okay. So forces up equal forces down and forces left equal forces right. Okay, that is such an important conceptual thing, and it can help you solve the problems. Okay, so now we've identified all the forces in the x direction, and we've identified all the forces in the y direction. Let's write down the x component forces. All right, so x forces. Also, my favorite superhero team, where Deadpool made his first appearance. He was actually a villain in uh originally in X-Force. A lot of people think he was a superhero. He's not. He's a supervillain. Okay. So here is Deadpool. Okay. And Deadpool is he is a supervillain. Yeah, we'll just draw Deadpool right here. And he is he's a super villain. Okay, so there's Deadpool. He's gonna help us today. There's Deadpool. Okay. Deadpool. Let's draw some. He's got guns. Deadpool. Deadpool always has guns. Yes, there's Deadpool. Okay. All right. So we got Deadpool here because X Forces. Well, anyways. All right, so we got Deadpool there. So our X forces, we have TX and F of XY. Okay, so that means TX has to equal F of SX. Those are the only two forces acting in the X direction. Okay, so our forces left equal our forces right. Okay, now let's draw the Y forces over here. Okay, we're gonna do Y forces. All right. Now, in our diagram up here, we have one force going up. That's the component from the sail pointed upwards. Okay, so that's we'll say F of SY is going to equal, and the forces going down are his weight and from the tension in the cable. So we have weight plus the tension in the cable, TY. Okay? And that is a plus because it's in the same direction as the weight. The weight is the thing that we're solving for. Okay. So if we can solve this equation for W, we're done. So let's go ahead and get that into a form where we're going to solve for W. Okay. So W is going to equal, we've got F of SY minus TY. All right. So we have the equation that we need to solve to get W. If we find W here, right, problem over. That's the answer that we are after for. Okay, so that is what we are solving for. Okay, we're gonna write that here. So then we step 5, figure out what we are solving for. What we are solving What what are we solving for here? Okay, we're solving for W. Now we just need to get these components and we're basically done. Okay, so let's start with ty. How are we going to get ty? Okay, well, it tells us here, right? Our angle theta. This is actually angle phi here also. Okay, and so where's ty here? Well, ty is the opposite side of this triangle. T is our hypotenuse. Okay, so ty here is the hypotenuse of that triangle. Okay, and that is the opposite side. So let's write down what ty is. Okay, so ty is going to equal, okay, it's going to be the opposite side. So this is going to be, so our hypotenuse is t, and then since it's the opposite side, it's going to be sine of phi there. Let me make sure I am, yep, that's sine of phi. Okay, so all right, that's one thing that we need that we got. Okay, we got this one. Okay, we just figured out what that is. Okay, we know what big T is here, right? 2100 newtons. We know what our angle is, phi, 15 degrees. Okay, so we know everything for this. Now we just need to get f of s of y. Okay, so let's look at our diagram here. Okay, and okay, we don't know what the force is in this cable. Okay, we don't know what the hypotenuse of this triangle is here, but if we know what f of s of x is, okay, f of s y, we can just draw this one. Okay, we can just move this vector over here because it's really just this component right there. Okay, that is our vector right there. Okay, so this is f of s of y. Okay, that's our vector here. Okay, and this is a right triangle. I'm going to draw that little square there that tells you that this is a right triangle. So this angle there is 90 degrees. Okay, okay. So we know the angle of this triangle, and we know if we have y or x, we can solve for the other one, and we're going to find out what f of s the f of s, the force from the sail in the x direction. Okay, well that's just equal to the x component of tension. Okay, so we wrote that down right here. We can find t of x, right? So if we look at our triangle here, okay, well we've got an angle there phi. That's the same angle. Those two angles are the same. Okay, let me show you what I mean. I want to try and prove this to you. Yes. So those angles are the same because let's say down here I'm going to draw, make a new drawing here. Okay, if I have some angle like this, so if our angle is phi like this, okay, and then I draw a parallel line down here. So the bottom and the top lines are parallel. Okay, well, this angle here also has to equal phi. Okay, now we can prove that by doing this. We're going to do the following. Okay, so tear off the corner of my page, and I'm gonna copy. Okay, I am going to try and make a trace of this. Okay, yeah. Really wish I had a protractor, but I'm gonna get one next time I go to the charge. Okay, so there's my angle phi. Okay, so I drew that angle on that piece of paper, and okay, now I'm gonna take it over here. I'm gonna go like this. Okay, I'm gonna put it this way, and look at that. Indeed, it is the same angle. All right, I measured it. See, I used a little paper cutout there. Make this look look spiffy. Okay, get the scissors too. All right, so see, that angle is the same as this angle. Okay, so we're just measuring, right? I just drew it and I measured it. Okay, so I drew a little geometry here, right? We did a little geometry. We measured the angles. We found that they're the same. That is what experimentalists do. Okay, so this angle is the same as this angle. So we're trying to find t of x, right? The x component of our in our cable here, because that's equal to the x component of the force from the sail. Okay, and then we're gonna finally get to f of sy here. Okay, uh, all right. So t of x, let's write that down. Okay, so my hypotenuse of this triangle, I know what t is. Okay, so t of x is also going to equal t times cosine of my angle phi there, right? And that makes sense because ty was equal to t sine of theta. Tx is equal to t cosine of phi. I said theta, I meant phi. So ty is equal to t times sine of phi, and tx is also equal to t cosine of phi. Okay? So we've got t of x now. I know all the numbers for this. I can just plug that in. Okay? And this is also equal to f of s of x. Okay? Now, we're gonna use tangent. Okay? So my triangle up here, right? I know my angle theta here. Okay, if I know f of s of x, I can find this using tangent. I don't need to know what the hypotenuse is. I don't care. Okay, so I'm going to write that triangle up there. I'm going to have f of s of y divided by f of s of x equals tangent of theta. Okay, this is just my trig. Okay, this is my y component. In trig, you probably learned it as y over x equals tangent of the angle of the triangle. Okay, we're doing the same thing here, just with our forces. Zoom out here. Okay, so here's our triangle. Right, this is our triangle. So here's our y component. Here's our x component, and so we're just going to use tangent here. Okay, and let's see. Yeah. Oh, we're after f of s of y. Okay, and now we can get it. Okay, so I'm going to solve for f of s of y here. Okay, so f of s of y is going to equal f of s of x times tangent of my angle theta. All right. So now I know everything now. Wait, do I know f of s of x? Oh, yes, I do, because that's equal to t of x, which is equal to cosine of theta. Okay, so here we go. We are going to make this substitution right over here. We're going to go around here. We're going to plug that in there. Boom. Okay. I'm going to rewrite this. Okay, I'm going to substitute in there for t of x. So this will be f of s of y equals t of x times tangent of the angle theta there. Okay. And now I'm going to substitute in for t of x because I know what that is. I got a t of x here, and I'm going to plug that into right over there. Okay. Making those substitutions. So now I'm going to have f of s of y is going to equal t times cosine of phi times tangent of the angle theta. Okay, all right. It was a little bit of trig, just a little bit. But we did some good work here. Now we're gonna plug everything in. Okay, and uh I would wait till the end to put all this stuff in there. Okay. But let's write the whole thing out here. Okay, so we got our equation here for W. That is what we are after. Okay, so we're after W. W. There's a famous president that used to say W. I am G.W. Bush. All right. I don't know if you probably don't remember George W. Bush, but anyways, Um, W is equal to, so we're gonna have, we'll start here, f of s of y minus ty. Now we're gonna substitute in, right? We found f of s of y, so we're gonna have w equals t cosine of my angle phi times tangent of theta. And then I'm going to put ty here, so minus ty, which is t times sine of phi. Woo! That was pretty crazy. All right, now we're going to plug in the numbers, and then I'll throw to MATLAB. All right, so we got W equals 2,000, how many newtons was it? Oh, 2,100 newtons. See? There we go. I wrote that down right there. The angle phi, so we have cosine of phi, which is 15 degrees. So cosine of phi times 15 degrees. And then tangent of my angle theta, which is 30 degrees. So tangent of 30 degrees minus 2,100 times, that's going to be sine of 15. Whoa, almost ran out of room there. Okay. The good news is I am not going to make you do a problem with this much algebra on the exam. However, it's still interesting to know how to do this. Or maybe I will. I don't know. Anyways, do the practice exam. Very similar to what the test is going to be like. Very similar. And I say that and I'm serious about it. Okay, so we're gonna go throw all this into MATLAB. Alrighty, so I actually did this in chunks before, but now I'm gonna put it all together. All right, so there's the first part. We had I actually did this problem once and I forgot to hit record, and so this is the second time I'm doing this problem. And then we have minus, there we go, minus 2,100. Okay, we're gonna press enter. All right, so there we go. We gotta. Oh, and I didn't share my screen here. All right. So here we go. I'm going to put this into MATLAB. Okay, so I put in the tension here, 2,100 times cosine of d, which is 15 degrees, times tangent tan d, which is 30. Okay, minus 2,100, that's the tension, times sine of d times 15, which gives me 627.602 newtons. So I'm gonna write this down, right? So the weight of the parasailer is going to be 627.6028 newtons. Okay, that's what MATLAB gives me. And then of course this is too many significant digits. Okay. I think there's two in this problem, right? 2,100 newtons. So we're going to round this off. So W is going to equal 630 newtons. Okay, so I'm gonna zoom out here so you can see whole thing. Oh, and there's my little angle measuring tool that I made. I'll put that down here. Okay. Yeah, much higher. Okay, so all right, what are we solving for? Okay, so the last thing we did, all right, and then the final answer is right here. That is the weight of the parasailer. Okay. And I use that little angle tool to prove that these angles are similar. So what these are similar angles. Okay. And Deadpool gets shot in the head, but don't worry, he can regenerate. But the question is, does his brain grow back completely? I don't know. Okay. I know that he regenerates, but does his brain grow back completely right? I kind of think no. Yeah, brain tissue actually, in real brain tissue, it's very, I don't think you can grow back real brain tissue, right? If part of your brain dies, it's just kind of gone. And so we know that, if you lose part of your brain, if those cells are damaged, they do not regenerate. Okay. And, in a way, those cells are kind of circuits, right? All of your memories are stored there. And we know that because certain people have had traumatic brain injuries. And if part of your brain becomes damaged, you might lose the ability to speak or sometimes even walk. Now, the human brain is great because sometimes you can use a different part of your brain to learn how to do those things. Okay. All right. So what did we do after this? Let's recap a little bit, okay? We identified all the forces. We found the X and Y components. We set the X and Y components um, in net force equations, okay? We recognize that the forces are balanced. Forces left equal forces right, forces up equal forces down. And then we finally figured out what we were solving for. And then the last step was we um, um, solved solved the equations symbolically. Yeah, symbolically. Okay, so we didn't put in numbers until the end. I always recommend doing that because it makes it easier. You're less likely to get confused if you come up at the end with a big expression like this. You can put it all into your calculator. I think it's easier. All right, thanks for watching the video. Like and
Thank you, like and subscribe down below.
thanks.